Okay, hello Integrated Science, this is Mr. B, and we are going to finish up our section about the sun today. Again, to end the last video, we kind of looked at the surface or the atmosphere of the sun. There are certain features of the atmosphere of the sun that we didn't get to that were on that picture, and that's what we're going to wrap this section up with. So some of the features of some actual observable things that we can see on the sun's atmosphere. We have what are called sunspots, prominences, and solar flares. So a sunspot, this is an area of gas in the photosphere, surface of the sun there, that are cooler than the surrounding gases. Sunspots can be larger than Earth themselves. Um, if they could be seen apart from the rest of the sun, they would shine very brightly, and they're often found in groups that are associated with intense magnetic fields on the sun. So again, sunspots, a big thing, they're areas of cooler gas, and then they could be very large and again associated with intense magnetic fields. That's what a lot of these features of the sun's atmosphere are going to go with, and a lot of these are going to be connected. So just being able to understand the sunspot is just an area on the surface. Again, they can last from a few hours to a few months. The number of sunspots will vary in cycles, with about 11 years separating one sunspot peak from the next. And during the peak periods, there may be as much as 100 sunspots on the sun. So again, there will be times where there's a ton, but then it'll go back down. There's not very many, and again, they kind of move in cycles. And one kind of interesting thing, before we get to that, again, here you can see just some of the sunspots on the surface of the sun. Again, areas of cooler gases there. One kind of interesting thing about sunspots was the Italian scientist Galileo Galilei discovered that the sun rotates by observing the motion of sunspots. So he was able to identify the sunspots where they were at, and he noticed that sunspots near the equator move faster than sunspots near the poles of the sun. Man, saying the word suns a lot. So again, pretty simple connection there, that if the sunspots near the equator are moving faster, that means the sun is rotating much faster at its equator than it is near its poles. So again, Galileo Galilei, just kind of the big father of astronomy there, just always coming up with some interest. It seems like his name gets thrown around with anything, or with everything. Made a lot of interesting observations, one of them being the sunspots of the sun. Then we have what are called prominences. So these features of the sun's atmosphere all kind of connect with one another. A prominence is a huge loop of gas that will erupt from a sunspot region. And we're going to see a picture of what that looks like here in a moment. But they can extend upward from the photosphere into the chromosphere, and sometimes they can even reach into the corona. They can reach heights some of more than 100,000 kilometers above the sun's surface. They travel along magnetic field lines, and they will also connect sunspots as well. So I think, oh yes, here's a picture of a prominence. So a prominence right here almost forms an arch. Sunspot area right here, gas erupts from it. Again, that connects the magnetic field. Again, kind of why the magnetic fields are important between these two sunspot regions there. And then the last feature we're going to see a picture of here is what's called a solar flare. So right here, you notice we have it just erupting and it's not coming back down. So a solar flare just erupts completely from the edge of the sun. And so what a solar flare is that when the sun's surface sometimes will erupt dramatically, and it produces X-rays and hurls charged particles into space at speeds of more than 1,000 kilometers per second. And again, that's called a solar flare. Again, and those also usually occur near sunspots as well, and they can heat the corona to a temperature of nearly 20 million Kelvin. So that's a kind of a huge difference, where typically it's 1 million Kelvin in the corona. Again, these solar flares can increase to 20 million Kelvin. And they are so powerful, in fact, they can make the solar wind, which is there all the time, they can increase it to the point to where here on Earth it will disrupt electric power transmission and radio, television, and even telephone signals. Solar flares are a pretty hefty pop, or a pretty strong thing there. And so before you finish taking notes here, as a way to earn some extra credit on the quiz tomorrow, and again, let's see if anyone's paying attention past this point. If you write the word, again, I'll use Lincoln as an inspiration. If you write macaroni and cheese in the top left corner of your quiz tomorrow, I'll give extra credit. Again, if I see like 50,000 people writing that, then that means obviously someone told, and that you're not going to get any extra credit. But again, fewer people that actually listen this far, you'll get some extra credit there. So that's it for this video. Let me know if you have any questions.